also is affordable for others. Okay, I think that's all from me and my partner. Thank you for listening.
Thank you so much, Julius, for your insights on this topic. I would like to open the floor to judges for any questions or comments. Is there any questions or comments from the judges?
Yeah, hi. For the dealers so-called team, thank you for the so-called the community outreach that you have done to create the awareness for the use of recycling of the spent oil and to convert it to a usable product. In terms of the, I would like to look into the different aspect that will be the, how to say, the work-wise for the future potential. What you are expecting in terms of the outcome, in terms of the percent recyclability of the spent oil against the one soap making. So for example, how much of the material, the cooking oil that you are using to convert into one equivalent soap at about 600 grams, if I'm not mistaken? And what will be the conversion rate that you are expecting in this so-called in this product?
Okay. Okay. For this kits, we use 450 wasted cooking oil. So we have a 500 production of kits. So each student use 450. If we times with 500 students, so we can save around 200 and 200.
Thank you so much, Julius, for your insights on this topic.
Milliliter of wasted cooking oil. That's a lot of amounts if we compare.
Thank you. It would be nice if you are able to demonstrate in your presentation the percent conversion, or the, we call it in the industrially as a saving in terms of the environmental impact to the so-called
I would like to open the floor to judges for any questions or comments.
Thank you.
Is there any questions or comments from the judges?
Yeah, hi. For the dealers so-called team, thank you for the so-called the community outreach that you have done to create the awareness for the use of recycling of the spent oil and to convert it to a usable product.
Oil. And then
in terms of
for the waste cooking oil, we
would
need
like
to do some kind of treatment like filtration first before we use the kit to produce the soap.
Okay. I try to answer it. Okay, for the wasted cooking oil, we try to wasted cooking oil. Usually, we ask students to use their wasted cooking oil. If it's still dirty or smelly, you can put an organic odor remover, which is ginger, and then fry it for 5 minutes, and then you can use the waste cooking oil without the smelly smell. And then for the all students can also use the odor remover itself and put inside the waste cooking oil, so it can reduce the smell of the oil. And for coconut oil, why we use coconut oil? It is because coconut oil, when it react with the other chemical, it can produce bubbles. It can produce bubble that okay. It can make bubbles. So it is interesting if we use cooking oil that our product can produce more bubbles. In our previous video, we have shown that we have used this soap in washing our dishes, and it's truly produce bubbles. And smell good.
Okay.
Okay, that's all. Okay.
Hi, everyone. I'm Steven from UC Tunku Abdul Rahman. So again, a very interesting outreach programs from this soap making. So I just have a questions because we all know that the waste cooking oil basically also have quite a lot of usage that has been researched on so far. So have you compared with others alternative of reusing this waste cooking oil instead of soaps? Are you aware of any other alternatives?
Yes. I found that we can use the waste cooking oil and coconut oil to make detergent, but it needs the 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 amount of lye needed is a bit higher from making the organic soap.
Oh, so it's not viable compared to the soap.
Yes.
Okay, thanks for your answer. Thank you.
Thank you for the questions and the feedbacks from judges. So we are done with our 5 minutes of Q&A. So let us move on with our next group.
To continue, thank you so much. And we will now have G Square DC from University Technology Petronas. The stage is all yours.
Thank you very much, MC. Give me a minute to share my slides. Thank you. You can see my slide.
Yes, I can.
All right. So, hi, I'm Lo Jia Cheng.
And I'm Cheng Jun De.
Together, we're from UTP presenting the Haber-Bosch process in ammonia production. So speaking of the Haber-Bosch process, why don't we start with a bit of background? So the Industrial Revolution that began in the 1800s has caused the commercialization of the crop production, and this was mainly due to the rise in the population growth during this period. For instance, in the UK, the population has risen from 61 million to 260 million in 1761 to 1881. However, this has caused several problems. For instance, the initial nutrient resources, for example, from the human waste, the animal waste, or guanos could no longer sustain the commercialized agricultural activities. And this has caused the loss of important nutrients, for example, nitrogen, phosphorus, and potassium in the soil, and caused the drops in the crops production. And this inadequate production could no longer sustain the imminent population growth in the future. Therefore, in early 20th century, Fritz Haber and Carl Bosch has actually developed and industrialized production of ammonia through Haber-Bosch process. And in this process, they have reacted nitrogen and hydrogen to produce ammonia, which is the raw material of fertilizer. Yes, Haber-Bosch process is indeed important, but nowadays it had become one of the main process that contributes to the global warming condition. And this ammonia production from Haber-Bosch process actually consumes 4% of all the energy productions that is produced globally. And therefore, we have to seek improvement to sustainably produce ammonia as to reduce the global warming effect caused by this process. Therefore, our project objective is to review Haber-Bosch process for ammonia production, and we want to also investigate the sustainability of Haber-Bosch process in recent industrial application. And lastly, we want to study and review the technologies in ammonia productions and to know what are the impacts towards our environment and the economy. Move on, I'll pass the floor to Junda to review on the Haber-Bosch process.
Thank you, Jia Cheng. So next, let's have a short review on the Haber-Bosch process in terms of its reaction condition and reaction mechanism. First of all, the process temperature is usually maintained at 350 degrees Celsius. This is because the forward reaction of Haber-Bosch process is exothermic. Based on Le-Chatelier principle, a lower temperature would favor the production of ammonia. However, there's a drawback. If we are using a lower temperature, it will actually reduce the reaction rate. Therefore, the temperature selected is a compromise between the yield and the reds. This dilemma can somehow be solved by using a catalyst where it allows a higher reaction rate at a lower temperature. Next, please. Secondly, for the process pressure, it is maintained at 200 atm. Based on Lee-Chatelain principle as well, a higher pressure is favorable for the ammonia production because the molecule of the reactants are closer with each other, and this can increase the effective collision rate. Moreover, the conventional catalyst that is used in the Haber-Bosch process is iron-based catalyst. It is a very well-established catalyst as it has been used in the commercialized Haber-Bosch process for over 100 years. It is also low-cost catalyst, and at the same time, it allows promising ammonia yield in an acceptable time frame. Lastly, talking about the promoter that is commonly used in the Haber-Bosch process are potassium oxide or potassium hydroxide or molybdenum. A promoter is usually used to reduce the deactivation of catalysts such as poisoning, sithering, or caulking. By using a promoter, we can increase the efficiency for the overall Haber-Bosch process. Next, please. Now let's have a close look on the reaction mechanism of catalysis by using iron-based catalyst. First, it will start with an absorption process where the nitrogen and hydrogen molecules will be attached to the catalyst surface. And after the absorption process, it will follow by a surface reaction process where the ammonia molecules will be generated step by step. And last but not least, after the ammonia molecules was generated, it will be released from the catalyst surface through desorption process. As for the project outcomes and its impact, in terms of reaction rate, the reaction rate for the ammonia production have been significantly increased due to the utilization of iron-based catalysts in the Haber-Bosch process. Before the Haber-Bosch process, the ammonia production was only 3 liters per day in the year of 1909. But nowadays, after the introduction of Haber-Bosch process, the ammonia production have been improved up to 20 tons per day. Therefore, we can know that Haber-Bosch process is a more promising and efficient approach in terms of rate and yield as compared to the early methods such as Frank-Caro process. On the other hand, the introduction of Haber-Bosch process can also minimize the cost for the ammonia productions. With the improved production efficiency in the system, we can get great savings in terms of energy and operating costs. Based on the study that we have found, the average production cost for the Haber-Bosch process is around $4,000 per ton. As a result, Haber-Bosch process is the most economical process for the fixation of nitrogen, and with the modification continue in use, it is one of the most basic and common processes in the global chemical industry. And now I would like to pass back my floor to Jia Cheng to further explain about the social benefits and impacts. Thank you.
Thank you very much, Rinder. I will continue to the social benefits and the impacts of Haber-Bosch process. The Haber-Bosch process has diversified the use of ammonia or the ammonia derivative products. For example, the ammonia that is produced from Haber-Bosch process is very important in the agricultural sector, explosive or fiber producing sector. However, the most important benefits or impacts of ammonia is actually increase the food production over the years to sustain the population growth up to 70%. It is because the ammonia is one of the raw materials for producing the fertilizers. And with that, we could effectively achieve the second sustainable development goal, which is zero hunger. Yes, Haber-Bosch process is very important for development, and we can't deny the fact that it has contributed a lot to us. However, Katrish Mathiram, who is a chemical engineer from IT, he mentioned that ammonia production is also one of the main source of carbon dioxide release, which is the release of greenhouse gases that would definitely cause global warming. And from this figure, we can see that the ammonia accounted most for the carbon dioxide release from 1990 to 2013, consisting of 1.2% of global CO2 emission. And therefore, it is important for us to make modifications or improvements to increase efficiency or reduce the energy usage of ammonia production. For example, the modification that we can do is through doping of cobalt with the iron catalyst. And this process can be done by doping 2.5% of the top layer of iron with cobalt. And this dop layer could definitely is found out to be effective to increase the rate of reaction by 2.3%. And it is expected that this doping could help to decrease the production cost, at the same time reduce the energy required to produce ammonia. Back to you, Junda.
Thank you, Jacheng. So talking about the ability for industrial scale-up, for Haber-Bosch process is definitely not a problem, since it was a well-established scale-up process for more than 100 years. It was first successfully scaled up by a chemical engineer who is also one of the inventor, Carl Bosch, in 1910, and he was awarded Nobel Prize for his achievement in scaling up the process. The first industrial level ammonia plant was operated in 1913 at Opel plants in Germany with a production reaching 20 tons per day. Nowadays, the modern ammonia production plants are able to produce more than 3,000 tons per day in one production line. As you can see, the following two figures are the process flow diagram and also production flow chart for a scale-up ammonia plant. Next, please. In conclusion, Haber-Bosch process is a very significant and essential process to human life, especially in agriculture and pharmaceutical field. As we can see from the following graph, as the year and times progress, the food fertilizer production was increased linearly with the help of Haber-Bosch process. Therefore, it clearly shows that the Haber-Bosch process is a very good example that applies chemistry as a tool to enhance the ammonia production, and it shows how impactful it is to the human life qualities and also industrial development. That's all from our group, J2DC. Thank you very much for your attention.
Thank you very much.
Thank you so much from the group J2DC. Now I will open the floor to the panel of judges to give their question and remarks for 5 minutes.
Hello, yeah, Chua here again. I have one straightforward questions. We are talking about all the processes and the enhancement, but I did not hear about anything talking about the conversion efficiency, whether with or without catalyst or some other modification of the so-called processes. Can you perhaps enlighten us? The keyword here will be the conversion efficiency.
All right, sir. I think I can try to answer your question. Thank you, sir, for the question. So based on the study and literature review that we have conducted, the conventional Haber-Bosch process is using iron-based, like I mentioned just now, iron-based catalyst. And as we see more articles and literature, there are more innovation and also modification on the process by changing the new catalyst for the process, which can increase the production and also the yield and also to reduce the pressure and temperature required for the process. So if we comparisons, if we compare, of course, by using an iron catalyst, the performance is not as good as the new catalyst. Like for example, we did found some new catalysts, for example, like nitride or oxide promoted metals, such as using cobalt or nickels. But these catalysts are not so well established as the iron-based catalysts. And also, if we compare the cost, actually the iron-based catalyst has a lower cost than the new emerging catalyst. And also the new emerging catalyst is still under the development stage. So the researchers are still finding the stability and also the related study regarding the new catalyst. Therefore, it cannot give promise guarantee any promising outputs or performance to our process. So that's why we will suggest to use a conventional, which is the iron-based catalyst for the process.
So I would like to add on a bit regarding his explanation. So basically, what we have observed is that before the Haber-Bosch process, because Haber-Bosch process is indeed using iron as a catalyst to increase the rate of reaction, and before the Haber-Bosch process is like, for example, Brick ID or Frank Caro process, they didn't use like iron as a catalyst as to increase the rate of reaction of conversion of nitrogen and hydrogen to ammonia. And before that, we can see like in this slide we have mentioned actually like before Haber-Bosch process it was 3 liters per day. And then now it's like after the application of Haber-Bosch process, it's actually like 20 tons per day. And we can what we have found is the literature is that the Haber-Bosch process actually increased the rate of reaction by 60 to 65% of the efficiency. Yeah.
Thank you.
Yeah. Thank you,
sir.
Thank you for the question.
Just a question or you are comparing to before Haber-Bosch and after Haber-Bosch, is it not some enhancement of the Haber-Bosch process itself? So for now, Haber-Bosch is still the best process to produce ammonia.
Yes, sir.
Is that what you mean?
Yeah, Haber-Bosch process is like currently is still the most economical comparing to the other process, because like there are new technologies or developments done to like improve the process of ammonia production, but those processes are quite expensive in the sense that it's not economically sustainable for the ammonia production. Yeah.
So far from your knowledge, in these 100 years of the Haber-Bosch process, does any improvement in terms of like CO2 reduction have been made so far?
Currently, in my knowledge, is that the Haber-Bosch process is still like one of the main source of CO2 like releasing factor, because like population growth is increasing, and definitely we need to improve our agricultural production sector, and we need to produce more food to feed more mouths, and definitely the producing of fertilizers will definitely like the production of fertilizer or production of ammonia will definitely increase the CO2 emissions. But to respond to your questions, according to my knowledge, I found out that like improvements of Haber-Bosch process is definitely through doping. Yeah, the most common one is through doping, which is mixing of nickel and the iron, so that it can definitely improve the rate of reaction. Yeah.
Okay, thank you.
Hi, participant. Thanks for your presentations. So I'm Steven from UC Tungau. I just have a simple question. So basically, as we all know, again, this Haber-Bosch process is very energy hungry and energy intensive. So if you guys were to pick one improvement on the energy consumptions, so which methods will you guys choose to improve the energy consumptions?
Yes, sir. Thank you for your question. So for me, in my opinion, I think like Jia Cheng presented just now, I think for me, I think I will go for the doping, because it is doing modification on the catalyst so that the energy consumption is not so high, and also it will require a low temperature and pressure condition for the process to undergoing. So this can really actually save the cost for the production cost, actually like energy, because we all know the energy generation will require a lot of we release a lot of CO2, and also it will cost a lot of money. So I think through doping is one of the best way to deal with these situations.
Okay, thanks for the answer. Thank you.
Thank you, sir, for your questions.
Thank you all the judges for the questions and the feedback. So unfortunately, we are on time constraints, so we have to move on with our next group. So now we have witnessed 3 groups so far present their remarkably amazing concepts on how chemistry can enhance productivity. Now let's welcome our 4th group, Simple Solution, another representative of University Technology Petronas. Please welcome.
you guys see the slide? Good morning, everyone. My name is Amanda, and we are from Simple Solutions. So in line with the theme, Chemistry as a Tool for Enhancing Productivity, today we are going to present on the title, which is Hydrogen Production Using Molybdenum Disulfide Electrocatalyst. So in the first part, I'll be covering on hydrogen production based on water electrolysis. And first of all, let me introduce a little bit on what is hydrogen energy. So hydrogen is the simplest and most abundant element in Earth and significantly become one of the most important energy due to the increasing demand and as a cleaner and greener alternative to replace fossil fuel. And in order to solve the climate changes and temperature rise issue by
I am sorry to interrupt, but Amanda, you are breaking up. Could you please check your connection?
Of energy. Yes.
Your connection is breaking up.
Oh, okay. So, shall we start again? Is it okay? Sorry for the technical issue. Okay. In order to produce hydrogen, based on the current state of art, there is three major pathways. Where 50% of the global demand of hydrogen still relying on steam reforming of natural gases, where it is a low cost to emit large amount of greenhouse gases. And 30-40% is relying on chemical process of coal reform from the oil refinery, plus its electrolysis. Hydrogen is India. Sorry. If I start again, so hello? It's me.
Hello. Yeah, can we suggest Jinhui to proceed with the presentation because Amanda is breaking up.
So maybe she will share the same screen as mine. Is it okay? And
sure.
I'd like to start again if it's possible.
Sure, sure.
Hello. My teammate is facing some difficulties in terms of her Wi-Fi connection. So I think she can use my screen for a while. Is it okay? And we shall start again. Is it okay? If so, could you give me a reply? Thank you.
Dear Simple Solution participants, you are given extra 2 minutes, so you may start again.
Sorry. Did you hear what I said just now?
Yes, it is clear. Yeah.
Okay. Thank you. So I shall share the screen again, and thank you all for understanding. Yeah, sorry for the technical issue. So I will be presenting in behalf of the screen of my teammate. Yeah, and I will start now. Okay. Good morning, everyone. My name is Amanda, and we are from Simple Solution. So in line with the theme, Chemistry as a Tool for Enhancing Productivity, today we are going to present on the title, which is Hydrogen Production Using Molybdenum Disulfide Electrocatalyst. So in this part, I will be presenting on So in the first part, I'll be presenting on hydrogen production process based on water electrolysis. And first of all, let me introduce a little bit on hydrogen energy. So what is hydrogen? Hydrogen is the simplest and most abundant element on Earth and significantly became one of the most important energy due to the increasing demand. And it is a greener and more cleaner alternative to reduce fossil fuel in order to solve the climate changes and temperature rise issues by achieving decarbonizations in energy. So in order to produce hydrogen, there is three major pathways. And based on the current state of art, nearly 50% of the supply demand of hydrogen is still relying on steam reforming, which is a lower cost process. However, it will contribute to hydrogen and carbon dioxide emissions, and 30 to 40% will based on coke and naphtha reforming, and 4% is actually generated based on electrolysis. However, in near future, electrolysis is estimated to be one of the main process to produce clean hydrogen production. So the produced hydrogen can actually wide applicable in terms of power generation, thermal heat storage, fuel cell vehicle, and as industrial feedstock. So as I mentioned just now, in order to achieve zero carbon emissions, we need to take in considerations of green hydrogen. And what is green hydrogen? So green hydrogen is actually produced based on renewable energy, where the solar, wind, or hydropower power supply can be fed into an electrolyzer to split the only raw material, which is water, into hydrogen and oxygen. And this process will actually achieve net zero emissions, and the compressed hydrogen can be stored either as gas or liquid and transported to use as fuel. So next, I will be, for today's discussions, we are focusing on proton exchange membrane electrolyzer. So proton exchange membrane electrolyzer is first developed in year 1966 by General Electric in order to overcome the drawbacks of alkaline water electrolysis. And proton exchange membrane electrolyzers actually possess various advantages, including high purity, fast response time that it can enhance the production rate of hydrogen. And as you can see from this schematic diagram, so water will actually fit into the system and react at the anode part to split into hydrogen ions and oxygen. And the hydrogen ions will travel across the membrane to the cathode and react with the electrode from the external circuit to form hydrogen. And in this process, to enhance the catalyst, to enhance the activities in the anode, we have to introduce a catalyst. So next, I will be explaining how the catalyst can enhance the productivity in this water electrolysis system. So in terms of thermodynamic and kinetic mechanism, as you can see from this graph, based on under Gibbs free energy, which is the minimum cell potential, is the reversible voltage, which means that this is the minimum voltage we need to use in order for the water to split into hydrogen and oxygen. And the standard potential is 1.23 volt. However, in terms for the reactions to react thermodynamically and kinetically under endothermic reaction enthalpy, the thermoneutral potential is 1.48 volt. And the differences between the voltage actually contributes to overpotential, which means a higher potential need to be supplied into the water splitting in order to break it into hydrogen and oxygen efficiently. So by introducing electrocatalysts, we can actually overcome the problem of overpotential by lowering down the activational kinetic barrier, as you can see from this graph. By introducing catalysts, the energy consumption is lower and it can speed up the rate of reactions without increase the voltage. And based on the current research, platinum catalyst is widely used in PEM electrolyzer as it is very stable, and it has the highest current density and can overcome the most difference in the overpotential issue. However, it is very expensive and rare on Earth, and it will contribute significantly into the increase for the capital cost in commercialize. So in order to solve this problem, we need to develop an inexpensive and earth-abundant electrocatalyst. Therefore, now my partner will be introducing on how polyvinyl disulfide can enhance the reaction. Yeah.
So we shall introduce you molybdenum disulfide. We shall discuss on how it is applied as an electrocatalyst and its future prospects. So let me give you a small introduction of molybdenum as a heterogeneous catalyst, which was widely used in petroleum and plastic industries. And in the beginning of 2010s, molybdenum also contributes as an alternative for platinum in the hydrogen evolution reaction. So let's see how this works. So in this small video, you can see the surface adsorption of the hydrogen electrons. This is done by using the molybdenum disulfide catalyst. So molybdenum disulfide catalyst has a 2D layered structure with each layer stacked upon each other. This unique crystalline structure contributes to the higher catalytic activity due to its increased number of catalytic sites. So from this, the activation energy is lowered and the rate of reaction is higher. So allow me to explain why we have chosen molybdenum disulfide to replace platinum as an electrocatalyst. In terms of its cost and abundancy, molybdenum disulfide is a more economically feasible catalyst compared to platinum. As you can see from here, the price is way much cheaper compared to platinum. However, in terms of its efficiency, platinum remains as the winner. As you can see from this graph, platinum requires less time to produce more amounts of hydrogen gas. So, in short, both of these are capable as electrocatalysts. However, molybdenum is less efficient. So, how should we overcome this issue? Because we would like an economically feasible electrocatalyst to replace platinum. So, let us see the future prospects. Nanostructured morphologies are introduced because studies have shown that through different nanocomposition and morphology, the catalytic efficiency of molybdenum can be improved. So we can morph molybdenum into different types of nanotubes or morph it with graphene to form nanocomposites or other nanomaterials. And I would also like to note that the University of Wisconsin has reported that metallic phase molybdenum disulfide nanostructure enhances its catalytic performance due to higher electrical conductivity in the hydrogen evolution reaction. So in other words, there are two types of molybdenum disulfide nanostructure. One is metallic phased, the other one is semiconducting phased. So in order to achieve the metallic phased one, we will have to choose the correct preparation method, which is the exfoliation method. So from here, we can further enhance its performance, and this is how we can further improve the efficiency of the molybdenum to make it similar to platinum. And this is a TEFL slope, which I have mentioned that these are the researchers done to make it as similar as possible compared with platinum. So I believe that with more research, it can achieve the similar rate or even higher. So I've covered the future prospects. Let us move on to the societal impacts. So if we would use this electrolyzation process with the aid of this electrocatalyst, it would significantly achieve lower carbon emission rates, because carbon emissions are a very concerning issue because it relates to a lot of environmental problems. Next, hydrogen itself is already a clean and renewable energy, and I believe in the long future it will become a better option to replace the ever-depleting non-renewable fossil fuels. And then, hydrogen is a highly efficient energy source compared to other green energies such as solar and wind power. So I believe that with this technology, we can hugely exploit the benefits brought by this hydrogen fuel. In conclusion, we have talked about this hydrogen fuel production, which is nearly zero carbon emission, and with the use of molybdenum disulfide, which has excellent stability, high activity, earth abundancy, and economically feasible price, hydrogen fuel production using the proton exchange membrane electrolysis can be upscaled with the aid of this electrocatalyst to create a cleaner and more sustainable future, because it is a better option compared to platinum in terms of its economy price. And with that, I would like to end my presentation. Thank you all for attending. And these are the references.
Thank you so much, Simple Solution, for your wonderful presentation. Now, I will invite the panel of judges to give on their comments as well as questions.
Hi, thank you very much for the presentation. It's quite clear. But we would like to understand what is the next step for you to move forward if you are given a chance to use or to apply your presentation content towards the upscaling.
Okay. So I would leave this answer to Amanda, my teammate.
Okay, so for our discussion today, we actually wanted to introduce molybdenum disulfide in terms of like molybdenum disulfide is a cheaper way to achieve the same efficiency, and by introducing molybdenum disulfide, we can actually upscale the electrolyzing plant, and in future it can actually propose as power plant or fuel power plant into medium scale or even commercial scales to provide hydrogen productions in future. Yeah. So by introducing molybdenum disulfide is our first step that we can lower down the cost and enhance the productivity in this proton exchange membrane electrolyzer.
Thank you.
Thank you.
Are there any questions from the judges?
Hello, I'm Steven from UC Tunggal Perumal.
Hi.
Okay, so that's a very good, interesting presentations as well on the molybdenum disulfide. So just a simple questions again. So since you are proposing to use molybdenum disulfide, are you aware of any disadvantages or is hazardous properties that's associated with it? Can you clarify it? Yeah.
So I believe that the term disulfide would concern a lot of people because maybe for some people they would think that the sulfate ions would be released into the electrolyzer system and then it would produce some toxic gases, I believe. So in terms of this, maybe molybdenum disulfide, because this is just one form of molybdenum. Molybdenum can become molybdenum oxide or molybdenum with vanadium or even iron to become a suitable catalyst as well. So it doesn't necessarily need to be molybdenum disulfide, but molybdenum disulfide itself is the basis of the many branches of this wonderful catalyst for these types of reactions.
Okay, thanks for answer. So it's good to take note of the precautions because when you introduce something that has a risk involved. Okay.
Yes.
Thank you.
Okay.
One question. If we use molybdenum disulfide, the spent catalyst or the used catalyst, can we recycle back or turn into something else for other application?
Okay. So, like many heterogeneous catalysts, molybdenum disulfide has a longer span life. So I believe that the span life is very long until I would estimate it would take a few years for it to become unusable. So if it were to become another type of material, as you can say, it's recycled, because molybdenum is also a very tungsten metal. So maybe it can become a type of alloy for another type of production. So molybdenum itself, molybdenum disulfide is also a type of lubricant. So maybe it can be melted and become a type of lubricant component for other productions.
So I just want to add on in terms of the process-wise. So in the electrolyzer system, the catalyst introduced, like the molybdenum disulfide introduced into the cathode side, is actually based on absorption and desorptions. So there is no regenerations that involving, and where the electrode, the hydrogen ions will just attach on the catalyst side to react to form hydrogen, and it will dissolve, and the molybdenum disulfide can continuously use in a very long term inside the system to enhance continuously productions of hydrogen.
Okay, thank you.
I believe that is all for now. Thank you so much from Action Persuasion for their wonderful presentation again. Now we'll be heading to the very last presentation, and I would like to welcome to the stage ACES from University Technology Petronas. Please welcome.
All right, thank you. morning to all beloved judges, to all participants, and to all audience. In a beautiful day, me and my partner project would like to present our project, which is the title of biodiesel as an alternative fuel, and we are from ACS Group. So before we are going to start our presentation, let me introduce ourselves first. My name is Ahmad Danish Daniel bin Ahmad Nazri, and I am from Foundation in Mechanical Engineering.
My name is Yasmin Salika binti Abdullah from Foundation in Petroleum Engineering.
So, basically, this is our content that we are going to convey in more details after this to all of you, and I hope you guys can enjoy our presentation. Before any further ado, let's get started. So, ladies and gentlemen, currently we are still dependent on fossil fuel to produce energy for our industries and our transportation.
Slow down your BTM because your voices are not clear.
Okay, sure.
Thank you.
All right. Did you guys know that fossil fuel is a non-renewable sources? It means that if the sources are finished, energy could not be supplied. So we are represent biodiesel as a substitution for our fossil fuel currently. So it also can give an impact to the price of fossil fuel month by month. As we could see at petrol station, the price of petroleum are increased just in 1 year, as you guys can see on the graph appear on our screen right now. So other than that, fossil fuel will give an impact to the environmental pollutions such as air pollution because of the consumption of gases from fossil fuel. So the global climate also occurs because of the combustion of fossil fuel that will be produce carbon dioxide. More emission of carbon dioxide molecules in the air will increase the temperature of our weather. So as in the graph, as you guys can see right now on our screen, daily global carbon dioxide emission was increased based on the graph from 1960 until 2020. But as we make here, on 2020, the carbon dioxide emission was slightly decreased because of the pandemic was happened. So there is no transportation and industries allowed to happen last year. So it proves that the carbon dioxide is the reason why the temperature of our country was increasing. So for our objective of our project will be explained by Yasmin. The floor is yours, Yasmin.
Thank you, Danish. The objective of this project is, firstly, we are going to reduce dependency on fossil fuel and maintain oil supply since fossil fuel is a non-renewable fuel. And secondly, we are going to reduce the environment pollutants as fossil fuel produce harmful emission to our air. And thirdly, we are going to make biodiesel as a main fuel in future or commercialize biodiesel worldwide. And lastly, we are going to enhance productivity rate of reaction in production of biodiesel. Next, Danish is going to explain about the process of biodiesel. Back to you, Danish.
All right, thank you, Yasmin. So, ladies and gentlemen, for your information, biodiesel is made up from the trans-esterification process. Okay, what is trans-esterification? Trans-esterification process is the process in which fat or oil reacts with an alcohol to form esters and glycerol. So, a catalyst is used to improve the reaction rate and yield because the reaction is reversible. Excess alcohol is used to shift the equilibrium to the product side. In a general equation, 1 mole of triglyceride will be react with 3 mole of alcohol will be produce 3 mole of alkyl esters and 1 mole of glycerol. So in this case, in our project, we're going to use the reactant of linoleic acid, which is the sunflower oil, and methanol to produce butyl acetate, which is the biodiesel that we need in our project, and also glycerol. So for the catalyst, we are going to use the sulfuric acid. So it is related with rate of reaction that will be explained by Yasmin again. Please be welcome.
Thank you, Danish. Next, I'm going to talk about the chemical kinetics with this chemical reaction since it's related with rate of reaction, in which temperature, catalyst, and concentration are the factors that will affect rate of reaction. Firstly, we are going to talk about the temperature. Temperature influences on kinetics and equilibrium of reaction. It diminishes the viscosity of products and improves the mass transfer. For temperature, we can say that as we increase the temperature, the rate of reaction will also increase. This resulting in the average kinetic energy as the temperature increases. At high temperature values, saponification is enhanced, leading to lowering the yield of butyl acetate. If cold solvent is used, the temperature will be lower than its boiling point to avoid vaporization. Therefore, a greater proportion of linoleic acid and methanol molecule will have minimum energy necessary for an effective collision, and making higher temperature particles to collide more often with more energy will speed up the chemical reaction. We also find that the optimum temperature for maximum production of biodiesel must be between 60 degrees Celsius until 80 degrees Celsius. When the temperature is higher than the optimum level, it will cause the reaction to yield significantly. For catalysts, we are using sulfuric acid. When sulfuric or sulfonic acid is used, a very high yield of alkyl ester is obtained. In this case, the reaction mechanism is acid catalyzed. The use of catalyst is to speed up the chemical reaction by lowering the activation energy for the chemical reaction. The amount of catalyst had positive effects on biodiesel yield, in which increasing the yield of biodiesel with the increase in catalyst concentration. Thus, increases the amount of sulfuric acid as the catalyst will also increases the rate of reaction. For concentration, if we increase the concentration of methanol as solvent, it will result in more of chemical present, leading more reactant particles of methanol to moving together and allowing more effective collision to happen, thus increases the rate of reactions. Once again, the higher the concentration of methanol, the higher the rate of reaction. Next, Danish will explain about the advantages of biodiesel production. Danish, the floor is yours.
Thank you, Yasmin. So, basically, the advantages of biodiesel is biodiesel can produce less carbon residues, which means it will leave less carbon buildup in the diesel engine compared to petroleum diesel. It can also reduce the consumption of fossil fuel, thus reduce the carbon dioxide emissions because it is a carbon neutral. And thirdly, biodiesel can improve the economy for our country since we are going to be the supplier of biodiesel. And lastly, biodiesel can minimize costs for the oil rig investment, as for the example to get the petroleum. Back to you, Yasmin.
Okay, our expectation toward this project is that biodiesel should be commercialized around the world in order to enhance the world economy and also replace fossil fuel, since the price of fossil fuel inflamed up recently. One step that we can take is by approaching the government to make biodiesel as a main fuel in our country. In order to do that, we can do a proposal for a 10-year plan with a full case study and proof of concept to the government. The purpose of biodiesel production optimization is to find the value of variable involved in the process that maximize the profit, minimize the cost of the process, or maximize the yield of biodiesel so that the process become competitive in the fuel market. Lastly, Danish will briefly talk about our project's conclusion.
All right, to wrap up our project, biodiesel will be an attraction in future as it is a renewable sources that can maintain the energy supply for our country and our world. So, the variable rate of reaction techniques was investigated to ensure the production of biodiesel with more efficient and can minimize the cost of the production of biodiesel. So, biodiesel will most likely progress toward balancing market demands with community and consumer perspectives. Because of their lower cost, availability, and environmental friendliness, the development of alternative sources for green biodiesel is essential for future. Few innovations have been established are yet to be developed with a greater improvements. Thank you for your attention and hope to see you guys again. Thank you very much.
Thank you very much, ACES, for your input and your sharing. I open the floor to judges for any comments, questions, or feedbacks.
Can I start first? Okay, two questions from me. Why do you choose sunflower oil since it's not native in Malaysia? Since you can choose like palm oil since we produce a lot of palm oil here. And then another thing is what are the other products that you produce from the trans-esterification besides butyl acetate? Is it the main compound?
All right. Thank you, Mr. Asrul, for the question. So basically, for your first question, actually we use the sunflower oil because of we made a research to get a chemical formula for the chemical equation. So there is a lot of sources to make a reactant to produce biodiesel, such as palm oil, as you mentioned just now, palm oil. What else? Palm oil, soybean oil, and also we can use cooking oil for the substance to make a biodiesel. But use cooking oil, we have to filter first before we go further to the process to make a biodiesel, because there is like a scraps meat, and then a water that is a mixture of compound in the used cooking oil. So that's why a bit difficult lah. And for your second question, there is a lot of product that to produce biodiesel. Biodiesel is not a main, butyl acetate is not a main product for biodiesel. There is a lot of biodiesel that is from from what we call it. From alkyl esters, so there is a lot of the name of other than butyl acetate, so like lactic acid. Sorry, I'm not sure for that, but there is many of the product of biodiesel, as long as it is alkyl ester. So I think that is question for the. I think that is the answer for your question. Thank you, Mr. Azrul.
If I may add to Mr. Azrul's question, actually we can use any plant that produce an oil to produce biodiesel. So the plants and crop that are most likely to be used, which is that would produce a lot of oil. So we can use any of them, such as soybean oil and coconut oil, algae oil, canola oil. It's just that the percentage of the production of biodiesel would be different. So we choose linoleic acid as it would produce the most biodiesel. I think that's it.
Okay. Thank you.
All right. Thank you, Mr. Azrul.
Are there any other questions from the judges or any?
Yeah, I have one question. It's a very good presentation. The one comment is when you define this as sustainable and cheaper resources, have you considered the price of the feedstock or the commodities that we are using today? And will you projecting that the crude oil will continue to surpassing the price of equivalent commodity that you're mentioning as your raw mat for your biodiesel production?
All right. Thank you, Mr. Chua. Actually, to be honest, the production of biodiesel is quite pricey lah. It means like it needed like more cost to make the research on this project. But when it is commercialized, I think it is not need high cost to produce a biodiesel. But in this case, the problem is the biodiesel still not commercialized until now, because it is under researching. Because actually by other countries in world like have used biodiesel in a small, a small usage, but not that commercialized to all society. So I think that is the answer for Mr. Chua. Thank you, Mr. Chua.
Thank you.
If I may add again, the biodiesel is kind of pricey than the normal fuel, but there is not much if to produce it, obviously. But in order for us to use it, we don't have to modify our car, as biodiesel we can use it for our car. We don't have to modify our engine or and so on. And then for now, I think it will not affect our feedstock for now. But as the technology advance, we could there is always a way to enhance without affecting our feedstock.
Thank you.
Thank you, judges, for all your questions, comments, and feedbacks throughout the session. Unfortunately, we are at a time constraint. So another round of applause to all our presenters in this session. May everyone take all the good points home from the session. Kudos to all. So that was a very pleasant way to end our last pitching session. Let's wrap up the session with another round of quiz. You may click the link given in the chat box or type in the code shown on the screen. We will wait for 1 to 2 minutes for participants to log in, and we will start the quiz, the game. The instructions are provided in the chat box, so we will wait for a few minutes before we start. Do join the game because great prizes await. Also, a reminder, audience may join the quiz by using the link or entering the quiz code through the quizzes browser. Please insert your real full name and click start to join the party. Once you have joined the quiz, you'll see your name appear on the screen share. We would like to remind you why using your real name is important is so that it will allow the organizing committee to contact the winners afterwards. This is a live quiz, so winners' names will be displayed on the screen at the end of the quiz. Ladies and gentlemen, we'll start the quiz session now.
Thank you for those who participated on our round 2 quiz. Ladies and gentlemen, it's already 12:48 p.m. and it's time for us to have our lunch. I would like to inform you that our lunch break is from 12:48 to 1:45 p.m. It will be a great pleasure to have you return to this meeting room on time. Please enjoy your lunch and thank you.
To those of you who have come in search of answers, seeking inspiration and looking to achieve your aspiration, this is the place where your inspiration, where you will be propelled to realize your aspirations. With today's global challenges, the role of the engineer, the scientist, and the technologist is transformed from being the technical innovator into being the agent of global change. Our world-class resources and faculties, our cutting-edge facilities, our global partnerships with leading universities, our strong network with industry for internships and job placements, our worldwide research collaboration. These are the inspirations and the opportunities at UTP. Here, we nurture the analytical skills and intellectual capabilities of all who walk the UTP path. Here we culture the ethics and the attitudes that will shine in the real world. Here we expose ourselves to what it truly means to be human, to be a valuable part of society, to be the empowered people, the game changers who will light up the path towards a better world and change lives for the better. At UTP, the torch is firmly in your hands. So hold it up high and let us together light it and let it burn brightly. Join us to seek inspiration and achieve your aspiration towards global prominence.
It's a place that gives me opportunity for higher education. I feel that this university is a very vibrant place. It's just amazing. World-class education system.
What comes to my mind is above expectation. Having graduated is also yet another memory. Most memorable experience for me was celebrating my lecturer's birthday because the community that time was very small. We were very close.
The good memories that you can have in the universities. There are many good friends that I still keep in touch with and I still have to. I think university days are more than just knowledge and skills and career, thinking about future. Like college days is really something that shaping our life.
My most memorable experience, we have this like a family of our, I think it was 7, 8 of us, very close. So all of us are still in touch until today. And we're going to have our mini reunion soon. So yeah.
What I enjoyed most is actually kayaking. We spend a lot of time outdoor and spend a lot of time on kayaks on the lakes around here.
I think my most memorable experience was when I was given a task to motivate and teach thousands of new students the UTP song during the orientation week.
UTP is very special to me because I come from a very humble background. Thinking of stepping into a university has always been quite a far-fetched dream.
Place that they teach me the analytical skills, the skills that is needed so much in my life.
My years at UTP were some of the best in my life. I walked into the real world as a UTP graduate feeling extremely confident.
What I like most about UTP is it's a melting pot of cultures. Particularly the environment here is very nurturing, very good for education actually.
If there's no classes, we'll go to Ipoh. That is an experience and a memory for us as well.
We download a Korean drama from another, I don't know where. And so we just watched Korean drama because nothing to do in Toronto.
I created and organized UTP's major events that have now become the university's annual functions.
In 2019, I won the Prestige 40 Under 40 Award. I must say that that award was given because of contribution towards different areas. So how did I get into this part instead of just focusing on engineering is because of my experience in UTP, where I was exposed to social developments through CSR programs.
Just like how I did with my IT, whatever I do up until today, I designed everything. If you look at tenure classes, I designed it. If you look at the school, I designed it. I'm proud to say I'm the product of UTP. At least I bring that with me.
My advice to UTP students, first, explore all possibilities. Then identify your passion, what you really want, work on it.
Do well, up your performance. Most importantly, be passionate about life. Find the purpose and meaning in your life as you will venture out in your working life.
To all UTP students and graduates, I just want to let you know how proud I am to be a part of the family. May we always keep up the tradition of being resilient, creative, and excellent.
Thank you, UTP, for unlocking the potential in me and shaping who I am today. I will always have UTP in me wherever I go.
How you doing?
Hi, great.
What's your name?
Kang.
Kang.
Nice to meet you.
Where about you? From Malaysia, right?
Yeah, I'm from Malaysia.
Excellent. How long have you been in?
About 4 months. I'm working on composite manufacturing, so I've been given a chance to work in the composite laminating room. Currently, composite manufacturing departments would like to implement a new technology into the composite laminating, whereby they use the laser positioning technology to reduce the time needed to manufacture this retail wishbone.
First time you working with CAD? Or
no, I learned some bits, pieces in university.
Yeah. What can you take home with you?
Yeah, definitely is the teamwork. Yeah, and they helped me to develop my skills bit by bit.
Excellent. Well, I hope your experience here has been great.
Yeah, it's great.
Hope the next 2 months you learn a huge amount so you can take back with you.
Yeah.
And you'll always be welcome back.
Yeah.
All right, buddy.
Nice to meet you.
And you. How you doing?
Hi, nice to meet you. My name is Praveen.
Praveen, nice to meet you.
Yeah.
How's your stay been?
It's been great so far.
You've been here for 4 months, right?
Yeah, since January.
Excellent. What have you been working on?
So I've been working in aero inspection, mostly because my supervisor Michael Fuller is in charge of that. So what we do is inspect all the parts before it goes to the model shop. I'm using like scanning equipment to scan the parts, also manual checks on the car.
Did you know what you want to do though in the future?
Not really.
Not yet.
I still have 1 more year to decide.
Okay, excellent.
Yeah.
Excellent. What's your favorite part of the Formula 1 car?
It has to be the front wings because they keep on changing it in the aero to make it faster and faster.
You're over in the by the wind tunnel.
Yeah,
all those guys are the best.
Yeah, I've seen you a few times there.
Yeah, I like going there, and I'm gonna go there today as well. I like to go and see what's happening with the car. Well, I might see you there later on, anyway.
Yeah, I think so.
Excellent.
Catch you later.
To those of you who have come in search of answers, seeking inspiration and looking to achieve.
Ladies and gentlemen, we will begin again in 10 minutes' time. Thank you.
To those of you who have come in search of answers, seeking inspiration and looking to achieve your aspiration, this is the place where you will learn to find the answers, where you will be motivated to discover your inspiration, where you will be propelled to realize your aspirations. With today's global challenges, the role of the engineer, the scientist, and the technologist is transformed from being the technical innovator into being the agent of global change.
Ladies and gentlemen, we will begin again in 10 minutes' time. Thank you.
Our world-class resources and faculties, our cutting-edge facilities, our global partnerships with leading universities, our strong network with industry for internships and job placements. To those of you who have come in search of answers, seeking inspiration, our worldwide research collaboration, this is the place where you will learn to find the answers. These are the inspirations and the opportunities to discover your inspiration, where you will be propelled to realize your aspirations. With today's global challenges, the role of the engineer, the scientist, and the technologist is transformed from being the technical innovator into being an agent. We nurture the analytical skills and intellectual capabilities of all who walk the UTP path. Here we culture the ethics and the attitudes that will shine in the real world. Our global partnerships with leading universities. Here we expose ourselves to what it truly means to be human, to be a valuable part of society, to be the empowered people.
It's just amazing. It's just
come to my mind is above expectation. Having graduated is also yet another expectation. The most memorable experience for me was celebrating my lecturer's birthday because the community that time was very small. We were very close. The community that time was very small.
There are many good friends that I still keep in touch with, and friends these are more than knowledge and skills and career, thinking about future and college career, thinking about future.
My most memorable experience, we have this family experience. Our this 7 a.m. very close. So all of the 7 keep in touch until today. I'm going to have our mini reunion today. Well, I enjoyed most actually. I spent a lot of time outdoor and spending time outdoors around here.
I think my most memorable experience was when I was given a task to motivate and teach thousands of students. They install during the orientation day.
UTP is very special to me because I come from a very humble background. Thinking of stepping into university has always been quite a far-fetched dream.
The skills that you learn so much in my life.
My years are so much spent in my life. I walked into the real world acting different and feeling confident.
What I like most about UTP is particularly the environment here is very natural, very good electrician,
If there's no classes, go to the Ipoh. You know, like that classes, experience and experience.
And so we just watch Korean drama because nothing to do in Toronto.
I'm created and organized because nothing to do in Toronto. That have now become the university as a country.
In 2019, I won the Prestige 40 Under 40 Award. I must say that that award was given because of contribution towards different areas. So how did I get into this part? Instead of just focusing on engineering, it's because of my experience in UTP, where I was exposed to social development, to CSR programs.
It's like how I do my IT, CSR programs. I designed everything. I designed it. I designed it. I'm proud to say I'm the productivity. At least I say that at least.
My advice to students: first, explore all possibilities and identify your passion. What you really want, work on it and identify your passion.
Out your performance, most important, be passionate about life. Find the purpose and meaning in your life, most important, be passionate out in life. Find the purpose and meaning in
To all
your life.
students and graduates, I just want to let you know how proud I am to be a part of the family. May we just always keep up the tradition of being resilient, creative, and happy. May we just always keep up the tradition of being resilient, creative, and happy. May we just always keep up the tradition of being resilient, creative, and happy. May we just always keep up the tradition.
Thank you, UTP, for unlocking the potential in you, shaping who I am today. Thank you, UTP, for unlocking the potential in you, shaping who I am today. Thank you, UTP, for unlocking the potential in you, shaping who I am today. Thank you, UTP, for unlocking the potential in you.
How you doing?
Hi, great.
What's your name?
Carl. Nice to meet you.
What about you from Malaysia, right?
Yeah, I'm from Malaysia.
What's your name?
Carl. Nice to meet you.
What about you from Malaysia, right?
Yeah, I'm from Malaysia.
What's your name?
Carl. Nice to meet you.
What about you from Malaysia, right?
Yeah, I'm from Malaysia.
What's your name?
Carl. Nice to meet you.
What about you from Malaysia, right?
Yeah, I'm from Malaysia.
What's your name?
Carl. Nice to meet you.
What about you from Malaysia, right?
Yeah, I'm from Malaysia.
What's your name?
Carl. Nice to meet you.
What about you from Malaysia, right?
Yeah, I'm from Malaysia.
What's your name?
Welcome back, ladies and gentlemen. We are back to our final and most awaited agenda, the winner announcements for today's event. I bet that everyone has been pondering upon the grand prizes and surely who to hold the champion title of NICC 1.0. As the saying goes, in every contest, there must be a loser and a winner. But be proud that you guys have made it this far in becoming today's
Lim Ying Moi. The second prize goes to Nur Maisara Asri. And the third prize goes to Satya Bama. Congratulations to all quiz winners. The second prize for the quiz winners, please be informed that you need to send your contact details such as full name and phone number to this email to all quiz winners in the chat box below. Thank you. Please be informed that you need to send your
the moment you all have been
such as
for
full
is
name and
finally
phone
here.
number to
The results are in our
quiz
hands.
winners in the chat box.
Everyone
below.
ready?
Thank you. Please be informed that you need
So without any delay, I would like to announce the winners for the high school category. The third prize goes to Congratulations to Open Heavia Brasiliensis. And now, drum roll please.
And the champion group is
Congratulations to Open Heavia
the Sparrow
Brasiliensis.
Academy
And
from
now,
SMK St.
drum roll
Mary.
please. Congratulations to all the
And the
groups that
champion
went to
group
the top
is
spots for today. Congratulations to Open Heavia. And now moving on to the undergraduate
from
category.
SMK St.
Drum roll
Mary.
please. Congratulations to all the
The
groups
third
that went
prize
to the top
goes to
spots for
group
today. Congratulations to
UTP
and now
from
moving on to the
J Square
undergraduate
DC.
category. And the second prize, congratulations, goes to
The third prize goes to group
UTP Simple Solution.
UTP from J Square DC. And for the first prize, drum roll please. The third prize goes to group
UTP Simple Solution.
from
The winner is Group Curie Sisters from University Malaya. Congratulations to all the groups for clenching the top spots for today and presenting your best in today's presentation. The winner is Group Curie Sisters from University
Heartiest
Malaya.
congratulations to all the
groups for
winners.
clenching the
We
top
are
spots
proud
for today
to see our
and
future
presenting your
leaders
best
effectively
in
pitching
today's
their ideas
presentation.
to tackle global
Curie
challenges.
Sisters from
As stated by Professor
Malaya.
I.R. Dr. Helmi Mukhtar, the youth is the hope of our future. We need them to be on board to tackle real-world STEM issues. We are delighted that the NICC 1.0 has provided the platform for the foundation students to showcase their impressive projects. Ladies and gentlemen, I would humbly welcome lecturers, judges, and participants to switch on their webcam for a photo session together. I will now pass the floor to the media department. I would humbly welcome lecturers, judges, and participants to switch on their webcam for a photo session together. I will now pass the floor to the media department.
Assalamualaikum warahmatullahi wabarakatuh. I would like to ask for all VIPs, lecturers, supervisors, attendees to open their mics. I would like for the photo session. I would like to ask for all VIPs, lecturers, supervisors, attendees to open their mics. For your information, there will be two different backgrounds. The first background is actually for formal setting, and then second one is for freestyle. So now I will put information. There will be for different background. The first background is actually for formal setting. So yep. And then second one is smile everyone. Okay, hopefully all of you can join. Different background. The first background is actually for formal setting. Just open your mic. So yep. And then second one is smile everyone. Okay, hopefully all of you can join. Okay. Everyone ready? Please, hope that all attendants can please open your. Okay. Please, you are still waiting for the lecturers. Hope that all attendants can please open their mic. Okay. Please, you are still waiting for the lecturers. Hope that all attendants can please open their mic. Okay, everyone. Still waiting for the lecturers. Ready? 1, 2, 3. Okay, everyone. Okay, please another one. 1, 2, 3. Now I will change the setting. The background. Please another one to freestyle. 1, 2, 3. Now I will change the setting. The background. Another one to freestyle. 1, 2, 3. Now I will change the setting. The background. Guys. Freestyle. 1, 2, 3. Now I will change the setting. The background. Guys. Freestyle. 1, 2, 3. Okay, ready? Please smile to the screen. 1, 2, 3. Okay, ready? Another one, please. Please smile to the screen. 1, 2, 3. Okay. I would like to ask for your cooperation once again, students. For the formal setting, I would like to take one picture because of technical problem. This formal. I would like to ask for your cooperation once again, students. For the formal setting, camera. I would like to take one picture because of technical problem. this formal, I would like to ask formal. I think that's all from me. Thank you very much, everyone, for your cooperation. Thank you very much, VIP, and attendees for your cooperation. That's all from me. Thank you very much, everyone.
Thank you very much to our department and everyone for your cooperation. So this marks the end of NICC 1.0. Once again, we would like to express our deepest gratitude to the honorable judges and everyone for your cooperation. So this marks the end of NICC 1.0. Once again, we would like to express our deepest gratitude to the honorable judges and everyone for your cooperation. It was such a pleasure to host the ceremony, and we wish you all a pleasant day. Thank you, and see you again. It was such a pleasure to host the ceremony, and we wish you all a pleasant day. Thank you, and see you again.
Thank you so much.
It was such a pleasure to host the ceremony, and we wish you all a pleasant day.
Thank you, everyone. Keep safe. Bye. Thank you so much.
Thank you. It was such a pleasure to host the ceremony, and we wish you all a pleasant day.
Thank you, everyone. Keep safe. Bye. Thank you so much.
Thank you. It was such a pleasure to host the ceremony, and we wish you all a pleasant day.
Thank you, everyone. Keep safe. Bye. Thank you so much.
Thank you. It was such a pleasure to host the ceremony, and we wish you all a pleasant day.
Thank you, everyone. Keep safe.